Good morning. Thank you for those of you who stayed from the first session. Welcome to those of you who are just joining us. My name is Gary. I'm going to be your host for the rest of the day. We have a new session coming up now. We have two more coming up after the morning break, so I hope you can come back and join us then. Quickly, I'm going to introduce our next presenter, Rafi Kardalian. He is, and always got to make sure I get the title right, our Senior Director of Private Cloud Engineering at Cisco, and he's going to be giving you a preview and introduction to the new Cisco Container Platform.
Great, thanks,
Rafi,
Gary.
all yours.
Morning, everyone. I head up private cloud engineering for Cisco, which encompasses two products, which we're about to talk about back to back here. The first one is our container platform, the second is our NFVI virtualization platform on Openstack, where our engineering director, Chandra, is going to come up and talk about that next. But we announced Cisco Container Platform at Cisco Live in Barcelona back in February. There was a lot of news made out there, primarily as a result of us announcing a partnership that we have with Google on this. So this gets into what we're going to talk about today, which is containerization and multi-cloud. So the theme that we've been talking about over the last couple of days has been how a single cloud is not enough. And that's been a trend that's been emerging pretty consistently over the last several years. Many organizations have an on-premise cloud. Many cases, there are multiple public cloud providers in play for a variety of different reasons. So part of what we're doing is embracing that and bringing the tools and technologies to the market to enable that and make that more seamless. So one of the products that's coming to market is our container platform. So no question at this point, the direction things have been going in terms of Kubernetes. There's lots of things that Kubernetes provides, lots of cloud-native applications these days. It's the predominant cloud-native application platform over which all containers are being orchestrated and deployed. So there's lots of things that Kubernetes provides. There's lots of things that it doesn't provide out of the box, much in the way that we've come to expect as a result of many of us having run OpenStack. It's a tool. It's not the only thing that you need to get up and running. So that's where our Kubernetes platform comes into play. So what are you going to need to operationalize a Kubernetes deployment? You're going to need monitoring, logging. You're going to need storage. You're going to need full lifecycle management. You're going to need to come up with high availability, resiliency for all the components that you're going to be deploying. So all of those are difficult, and they take time to deploy, and each organization would independently have to work through those rather than getting up and running if you were to deploy Kubernetes in your own data center. And that's where Cisco Container Platform comes into play. So it is 100% upstream Kubernetes. We are trailing Kubernetes releases by no more than a couple of months. So our first release, which is coming out actually today, is going to be released with Kubernetes 1.10, which is obviously the most current version of Kubernetes. As I mentioned, it is hybrid cloud optimized, so we have our partnership with Google. By virtue of that, we are ensuring a level of interoperability of workloads between Kubernetes deployments that are placed in CCP, on-premise, as well as those that are placed in GKE. So that'll be ongoing, and there'll be more announcements coming around that in the coming months. But again, it goes back to what we started on a couple of months back in the partnership that we announced. We have integrations throughout our Kubernetes or container platform for storage, for networking, for security, for analytics. So it's an all-in-one solution. And we've got a flexible deployment model. So what that means is today we're the initial release is designed to be deployed over top of our HyperFlex platform, HyperFlex 3.0. I'm not going to talk too much about HyperFlex today, but it's a VMware-based platform with a distributed file system or distributed block storage underneath in a hyper-converged solution. But beyond that will be moving towards having Cisco Container Platform being able to be deployed over top of bare metal, as well as other IaaS platforms such as OpenStack. So when it comes to availability, of course, we have to get to a point where we've got an architecture which supports failures. So as you might expect, we have a standard 3-node deployment architecture for our control plane. And I'll get into this a little bit more. But you can see we've got 3 Kubernetes nodes, 3 controllers, and everything is distributed there to be able to tolerate a failure of any one node. So all the elements that are behind there, the etcds, the databases that power our solution, every component ends up being 3-way active standby where it makes sense. But nonetheless, the point is that you can tolerate the failure of any one node. And this is an enterprise-grade solution, which is exactly what you would expect. It's curated. So all of the components that we put into our Kubernetes platform, we validated. We have complete coverage around this. Every piece is tightly integrated. There's a full suite of tests that go into each one of these. So as you deploy your Cisco Container Platform, you won't have to think through all of the different details such as CNI compatibility or storage or persistent layer. All of it is integrated. We have built-in load balancing and security. So there's a couple different models for how we're handling load balancing. I'll talk about that briefly. But it's all integrated as well into the platform. And then enterprise-grade persistent storage. Today it's based on HyperFlex, but there are more options coming in the coming months. So the first version of our container platform, I already talked about deploying over top of HyperFlex and persistent storage, high availability, but we've got integration with Active Directory for authentication. We have role-based access control. So the idea is much in the way that you see in OpenStack, where you've got your administrators, your cloud administrators, and you've got your tenants. We have the same concept in Cisco Container Platform, whereby a cloud administrator deploys and makes available Cisco Container Platform to their internal user base. And from that point, any user can sign up and deploy a container platform of their own. So the way to think about this is you have your Cisco Container Platform primary control plane, and then on demand, each of your users or any user can request their own Kubernetes cluster. So the way to think about it is if anyone has used GKE, you log into Google Cloud, you say, I want a Kubernetes cluster, you get one. So that's the same way that we've built Cisco Container Platform. So the same way, so consistent with that, each one of your end users who deploys a container platform or a Kubernetes platform gets all of the lifecycle management that is built into the product. So let me provide an example of that. Today we're deploying Kubernetes 110. Well, when we uprev Cisco Container Platform, what is going to normalize all of your tenant clusters? Well, Cisco Container Platform is going to handle that for you. So when you install CCP, is the acronym we're using for this, creatively enough. As you install that, we will normalize the clusters. Now, we won't force that upgrade, but the point is that you won't get the variance across your tenant Kubernetes clusters that you would otherwise have to deal with having disparate or dozens or hundreds of disparate deployments. Now, of course, this is a let's call it a situation where you might have lots of tenants, you might have fewer tenants, but nonetheless, there's going to be all of this lifecycle to manage. And it's not just Kubernetes. It's Docker, it's the operating systems, it's all of the packages that are provided by virtue of that operating system. And anyone who's operated infrastructure knows how much is involved in a stack like this. Much in the way those of you who've been deploying OpenStack, we are at the Openstack conference after all, understand how many components are involved there. There are just as many components involved here, and all of those are fully lifecycle managed. The other part is each one of these deployments gets its own EFK stack. So you've got your application you've deployed, and you want to see what's happening with your Kubernetes platform. Well, you've got access to full EFK. You can either use the Kibana dashboard that's included with your tenant cluster, or you can use Fluent to forward that off to an external ELK stack. So actually, today is our GA date for Cisco Container Platform V1. So this is, again, deployed on HyperFlex. It's licensed in addition to HyperFlex. Over the coming months, not too far out, we have the integration and integrated components being released to support our partnership with Google, and that gets us into V2. So the first iteration of CCP takes us from being supported only on top of HyperFlex to supporting generic VMware, at which point you can expect to see things like supporting any storage or persistent storage that is supported by VMware, so long as it carries a certain set of baseline functionality, snapshots, rapid cloning, et cetera. So all of that will be defined. But this is a key part of the first phase of our hybrid cloud story around containers, is this interoperability between CCP and GKE. I'm not going to talk too much more about HyperFlex. There is a lot of material that can be read up on HyperFlex. It's a very popular platform that we offer at Cisco. It's basically an integrated solution of storage and VMware, and now a container platform that can layer over top of that. So you get everything that you need to get up and running with VMs and containers in a single solution. So the CCP timeline, here we are in May. We just, again, are GAing now. We expect to get to V2, which will support the full interoperability with Google and GKE here in Q3. And then we're going to expand out to support more platforms. Now, there's a natural progression here in that you still, no matter what you do with the Kubernetes platform, the one thing that's frequently overlooked is you still need an IaaS below it. A lot of times what we're hearing about now is containers on bare metal. There's certainly a use case for that. But the more common case, and what of course all the public clouds are doing, is deploying Kubernetes over top of VMs. In fact, that's the most common use of Kubernetes, period, today. And that's why it's seen the uptake that it's had, even beyond OpenStack, is because you can deploy it anywhere. So you can have it deployed on your OpenStack cloud, you can have it deployed in Amazon, in Google, and Microsoft, wherever you decide to deploy it. It's a common framework for delivering cloud-native applications. So we intend to support a large variety of different deployment scenarios, again, to support this interoperability. But we'll be working with public cloud providers such as Google to enable that natively within our platform as well. Some other things that are coming beyond what I've talked about so far. We're doing optimization for AI and ML, machine learning workloads, doing CPU or GPU acceleration. So that's coming. And all of this I show is doesn't necessarily have a timeline. It just provides an idea of where we're going with this platform. We have integrations coming with a variety of different partners. Security integrations, companies that can do container security both in real time as well as scanning, as well as our own products at Cisco, such as Umbrella and AppDynamics. So this is just the beginning for us with CCP. Again, it's our V1 of this platform, and it'll be evolving pretty rapidly here over the next year or so. So it's a quick animation of just how things are going and doing a deployment through vCenter. To get up and running with CCP, you basically are doing an OVA import. So there's a process that it completely automates the deployment of your CCP platform or CCP over top of HyperFlex. And it really is a matter, once you've deployed HyperFlex, you can be up and running within an hour with CCP. So there isn't a high degree of overhead here. You get to make a few decisions architecturally about how you want to lay things out from a networking perspective. I'll talk about that briefly here in a minute. But the idea here is to eliminate any friction associated with not only the initial deployment of Kubernetes. There's lots of tools out there that can get you up and running with Kubernetes, KubeSpray, kubeadm, right? But how does that help you ongoing? Again, you have 1, 2, 5, 10 Kubernetes clusters. How do you deal with lifecycle management and consistent configuration of all of that? That's what CCP gets you. All of that is managed. All of that is handled for you. All of that is tested and integrated. So again, another animation here of being up and running or getting up and running, and just shows how quickly you can get going with creating a tenant Kubernetes cluster. It's a matter of putting in a cluster name, providing your SSH public keys, and the reason for that is so that you can log in and via SSH into the VM, so you can see exactly what's going on under the hood. Providing the location of your HyperFlex cluster, which is already predefined by the administrator, choosing a network, and data store, and you can use and choose your VM template. So quick to get up and running here. I'm letting the animation play out so you guys can all see. There's not a whole lot that has to be done to get up and running. Select the size of your cluster, and of course, through this process, it's not just an initial setup. You can, of course, expand and contract your Kubernetes cluster as needed. So under the hood, you notice here, there's no stand up of, let me talk to VMware and stand up more VMs and point at more VMs. All of that is being handled by CCP. So CCP is doing all the communication between itself and the underlying IaaS platform. So when we talk about future IaaS integrations, that's the level of integration we intend to have with any platform that we go over top of. So OpenStack, same thing will happen at some point. We'll have integrations that incorporate calling Nova, standing up VMs, attaching persistent storage, etc. So as I've been describing, CCP is a one-to-many Kubernetes deployment. In other words, we have a control plane for CCP itself that represents the CCP application itself, right? Everything that's managing, let's call it all the satellite Kubernetes clusters that are deployed alongside of it. You can see that each one of these is self-contained. So the control plane is self-contained. An administrator of the overarching platform has all the visibility. All of the metrics are flowing into it. Everything you would expect in a platform like this, Prometheus, EFK stack, the integration with various CNIs, it's all handled for you. And then a user can come in and say, I want a Kubernetes cluster. And you can see each one of those is stamped out as not just Kubernetes cluster, but all of the other tools that you need to fully manage your Kubernetes cluster, all of the monitoring, logging, analytics, et cetera. And we recognize that, okay, so you start off with this, and you might have a small tenant, right? You might have a small Kubernetes cluster, and the localized version of the EFK stack we provide gets you up and running immediately. But it's also designed so that you can say, I don't need these things. I'm going to now point to a larger deployment. So if this is integrating into a larger infrastructure as part of your data center, you can incorporate and utilize the larger deployment of those tools you have, such as an EFK stack or any log analytics platform, any monitoring platform. It's standard Prometheus, and Kubernetes, as I said, is upstream as well. So under that is HyperFlex, and when we call HyperFlex, the main thing that defines HyperFlex is the combination of using vSphere as well as the HyperFlex storage platform. I'm going to describe a little bit what that is. But if anyone has looked at a distributed block store such as Ceph, you kind of have an idea how this works. Of course, this is a hardened commercial version of a platform that you can rely on and get support from Cisco on. So it's an all-in-one solution. It's a little bit of a deeper look of how the HyperFlex servers are laid out. Again, I won't go into too much detail about this. But basically, you can see how things are broken out in terms of the various networks and VLANs. There's a couple different topologies that are supported here for deploying these environments. But this is, like I said, this is the next layer view of that. So once you're stood up with CCP, clearly all you need to do is either go into the UI, which we showed, and of course, all of this is backed by an API. So if you have applications and you have, let's say, a CI platform that wants to take advantage of standing up dynamically Kubernetes clusters using CCP, you can seamlessly do that by working through our API. Just like any modern application, everything is backed in by the API. In fact, there are more capabilities generally in the API than what you'll see in the UI, and that'll continue to expand over time. I'm going to skip over this. I've talked quite a bit about HyperFlex, but the main point here is that it's a distributed block storage. So what this does, by virtue of providing persistent storage as well as your IaaS platform and Kubernetes over top, is you get persistence in the Kubernetes layer. We'd like to think cloud native means that every single container that you deploy is stateless. That's not reality. You're going to have state somewhere. So we've got the ability to maintain that state through the persistence layer, and it's done in a distributed way. So you can continue to stack and add additional HyperFlex nodes, and CCP will take advantage of that. There are additional features in CCP coming as well to support things like auto-scaling and node pools, which will further expand on the scalability that we have in this platform and the seamless integration. We do get a benefit, of course, by virtue of being on VMware. Now, you should be building cloud-native applications if you're using a Kubernetes platform. However, we do support what is supported in VMware, which is we've got persistent storage. So if we need to do vMotion and move things around, we can do that. Now, this will, of course, depend on the IaaS platform that is underneath. But all of that is supported by virtue of HyperFlex and the distributed block store. So if you've got a workload that you need to keep up and running that isn't quite as tolerant, so you're in the process of converting to a cloud-native platform, you do have a way of stair-stepping that and getting there incrementally by using persistence and being able to do things like live migrations. We have a couple of CNIs that we've integrated. We wanted to provide choice here. The first is that we've got an ACI CNI. So if you have an ACI deployment with APIC, you can leverage this. Cisco Container Platform will fully take advantage of it. It's fully integrated with ACI. There are a number of benefits in that. I'll get to it in a minute here. We also have Contiv VPP. I don't know how many folks in here are familiar with VPP, but it was up on, it is actually up as one of the open infrastructure components that we've been talking about this week as FDIO. A number of folks are wandering around and can talk about that. But it is, think about it as parallel to OVS. In other words, you would choose it over, we think so, over OVS. Due to a number of performance benefits. And I won't get into VPP itself too much, but this is our own CNI that provides a number of performance benefits that was built at Cisco, that's been refined, that you'll find the core of in many of our core switching and routing gear. So there's a huge benefit to that, and it's, again, tightly integrated and tested against CCP. We also support Calico. It's a little bit different. I should say it's integrated rather than supported. The two former solutions, ACI and VPP, are what is supported. In other words, you can call TAC, and so long as you're running one of these CNIs, no problem. We'll walk you through it. The same isn't exactly true of Calico, mainly because of the variables in terms of the architectures it can be deployed with, but it is integrated. So if you choose to use Calico, it's there. We wanted to make sure we provided open options, and this will be a theme within CCP ongoing. In other words, there will always be choice. With storage, with security, whatever it might be, we'll have Cisco integrations as well as third-party integrations. So we do support Kubernetes network policies. Both or all three CNIs support that. I won't get into that in too much detail. So what's the benefit of the ACI solution? Well, you get to leverage all of the Kubernetes network policies that are then represented through your environment across your APIC-based deployments. So you can apply your ACI policy and have that match up with your Kubernetes policies. The main benefit, though, is that you get interoperability of your container platform from a networking standpoint with any bare metal you might have and other infrastructure you might have. So all of this is tied back in to a singular ACI deployment for complete integration. You get all of the, for anyone who's using ACI, you know the benefits of ACI. This integrates in ways that you would expect. So not required. But this is one of the models that is offered right out of the gate here with our V1 product. As I was describing, you get container to non-container communication. So you got in your ACI environment, you've got, let's say, a CCP, you've got bare metal, you've got another VM platform elsewhere. ACI, you can use the ACI CNI and stitch all that together for a seamless integration. Contiv VPP, again, it's upstream, you would find it as FDIO. So there's two components here. There's the CNI itself, which you'll see in the URL there as Contiv VPP. But there's also FDIO, which is the underlying virtual switch. It's not really a virtual switch, it's more of a packet processor. And you can find out about all that and read about it upstream, as well as contribute to any one of those projects. They're completely open. So this is actually Contiv VPP, and VPP are the default CNI for CCP. And the reason for that is not everyone has ACI. So if you don't have ACI, this is what you'll get unless you explicitly choose to use Calico instead. I have a lot of detail here on the Contiv VPP architecture. Not going to have time to get into this too much. But I'll share these slides, and if folks have questions, we can always circle back and answer and speak to any one of these. So within the platform, we do have L7 load balancing. There's a couple different ways that this occurs. One is that if you're using ACI, we leverage the built-in load balancing capabilities in APIC. If you're using Contiv VPP, then we leverage Nginx Ingress, which is pretty standard in a Kubernetes environment. And there's quite a bit of configuration that we support within this from the standpoint of load balancing. I've already talked about HA. I mean, this is a focus for us. This is an enterprise platform. We expect to be able to tolerate failures. We have persistence in the data store. We have the ability to fail over. There's some parts of it that VMware provides as well, but we're not as reliant on it. Prometheus and Grafana integration, again, this is there with each tenant, each Kubernetes tenant. It's not just a singular deployment for CCP. So each one that's stood up, each tenant can get visibility into their Kubernetes cluster. Same thing with the EFK stack. So all of your logging from your Kubernetes cluster for each tenant feeds into your EFK stack, and you get complete visibility into it. Additionally, as you saw, providing keys into, or as you're standing up your cluster, you're asked to provide an SSH public key. Your tenants can actually log in to their VMs if they need to do something on the VMs themselves to triage an issue, whatever it might be. All of that capability is there. Role-based access control. We have our initial cut at role-based. There's really two roles today. You're either an admin or you're a tenant owner. That will expand in the future to be much more configurable, to be able to say, okay, which operations can be performed by which roles. This does tie back into LDAP and AD. So the core components of what's necessary there to give you an admin plus tenant setup is available. The way we're versioning CCP is actually lining up with the Kubernetes when we uprev Kubernetes. And the main reason for that is an implicit consideration for lifecycle management. So Kubernetes supports N-1. In other words, Kubernetes 1.10, we can have, or N-2. So Kubernetes 1.10, for example, can interoperate with Kubernetes 1.8. But you can't go from 1.7 to 1.10 without having downtime. So to denote that and to make it evident in CCP, each time we uprev CCP, it'll be apparent in our version numbers. So when we go to Kubernetes 1.11, it'll be CCP 2.0. And the intent there is to make it such that you can go from, say, CCP 1.0 directly to 3.0. But you can't go from 1.0 to 4.0. And that becomes very clear as an operator in terms of what steps you need to do. And we also will normalize all the tenant clusters prior to an upgrade. Again, this is one of the benefits of CCP is this full lifecycle management for the platform as well as all of the tenant clusters. Here are all the versions and components that we've put into CCP itself. As I mentioned, the key one here is Kubernetes. Now, for interoperability's sake with public clouds, there are going to be some variances in this. Right now, we're matching up CCP with what our integration with GKE is going to look like. There will be more coming in this space in terms of matching up a Kubernetes deployment with the public cloud that we're integrating with, which again gets back to the lifecycle management aspect of the value of CCP, and that if you have multiple clouds, you're using, let's say, you're using Google, Microsoft, Amazon, and you're trying to create interoperability between all of those, well, the versions of Kubernetes, the versions of Docker, the underlying kernels, the operating systems, all of those things really need to be consistent across your clouds to ensure interoperability. And CCP will be able to manage that based on the integration. Again, today, Google is the one that's supported, but we're looking to expand on that. I'm not going to talk too much more about this. Many of you, I'm sure, have heard about Istio. There will be Istio coming in our product as part of the Google partnership in the next phase of CCP. I'm going to end there. So that's it. I can take a couple questions. We've got 10 minutes, Gary? Okay. Yep. So there are two SKUs. So the HyperFlex SKUs are separate from the CCP SKUs. So CCP requires HyperFlex, but clearly the inverse isn't true. CCP is not part of HyperFlex implicitly. You can buy HyperFlex, you can evaluate HyperFlex, and decide whether later if you want to go and add CCP to it. It's an additional SKU. Yep.
If I'm just an operator and concerned about getting my Kubernetes cluster deployed, but I'm not a CCP administrator, what's the process to get my Kubernetes cluster?
So as in you're an end user in...
Yeah, I just want to spin up containers.
Right. So if you have, let's just say, integration with your AD, and you've decided that a particular AD group is to have access to be able to have user-level access to your CCP environment, your users can then come and log in to the CCP dashboard. They will have basically a panel that shows, I don't have any clusters running. Click a button, and you get your own Kubernetes cluster. That gets stood up. All the information is given back to you in terms of what the IP address is, the ability to download your Kubernetes credentials, click in, and see the Kubernetes dashboard itself. So all of that is seamlessly exposed.
And what about giving group permissions to a Kubernetes cluster as part of the deployment? It looks like you could only insert SSH keys there.
For now, that's not there, but that's something that will come.
Actually, we got one here.
Yep. Oh, got a couple. Okay. The mics, yeah.
I was wondering how to think about your block storage roadmap in terms of persistent storage allowance. I saw Portworx listed in the future editions. And
Yeah.
You mentioned VMware. How are you picking, and how do you expect customers to think about those options?
So first thing is being VMware based initially. We've got a couple different ways that we can go about this. Anything that's properly supported as a vSphere persistent storage provider. The big ones, I mean, we think about NetApp, for example, is another one, SolidFire, EMC, and some of the newer players like Portworx, which are really cloud native storage solutions. So we expect to see a variety of these. My view is that there isn't necessarily one size fits all in most cases with storage. What we saw even throughout OpenStack and continue to see is tiered storage being the right answer. So we intend to provide a variety of different storage offerings, and it's really going to be workload dependent in terms of what's best for a given customer in a given use case. Yep.
Any work on federated clusters?
With Kubernetes federated clusters, that's coming too. There's nothing that's in the platform today, but that is coming, yes. Other questions?
5 minutes before they start serving coffee, so might as well take advantage of it.
All right, thank you, everyone.
Thank you, everybody.